So hi everyone, Namaste and welcome back to SJS CTET classes. So today in this video, we are going to see 4 important concepts related to number system. Okay, so keep watch the video till the end. Okay, and please do like, share and subscribe. So let us start. Okay, the first one is test for prime numbers. Okay, so if we want to check whether a given number is prime number or not, how that we will do, I can tell you within very short 4 steps we are able to do that. Okay, let's see how it is. For example, a number 123 is given to you. Okay, so how you will check whether this number is a prime number or not? The first step is, first of all, you need to find out a number which is just greater than this number and which is a perfect square. And we know that 11 square is 121 and 12 square is 144. So just greater than this number, we have the perfect square number as 144. This is the first step. Okay. Second step is you have to find out the square root of this 144. What is that? That is 12, right? And the third step is you have to find out the prime numbers less than this 12. So as we are aware of, what are the prime numbers less than 12? They are 2, 3, 5, 7 and 11, right? And after finding the prime numbers less than this number, then you have to check whether the given question number, right, that is this 123, is it exactly divisible by any of this given number, prime number? Is it exactly divisible? Yes, when you divide it, you can understand that this 123 is divisible by 3. Right? We will see the test of divisibility also in this video. Okay. So 123 is completely divisible by 3. So if the given number is completely divisible by any of the prime number, which we have selected here, then the given number is not a prime number. Okay. And then another example, 307. Okay. So what is the next perfect square number other than this 307? And next to that, it is 324 is a perfect square number. That is the first step. Then we have to take the square root of 324. That is the second step. That is 80. Then what is the third step? We have to write the prime numbers less than 80. So which are they? 2, 3, 5, 7, 11, 13 and 17. And now you check the given number 307 is exactly divisible by any of this number. So you can understand that when you can divide and check and you may be able to understand it is not completely divisible by any of this prime number. Okay, so we can understand that the 307 is a prime number. So this is the test for checking whether the given number is prime or not. Understood? Okay, so we are moving to the next one. See, whenever a number is given to you, you know how to prime factorize a given number, right? For example, you know 12 can be written as 2 into 2 into 3. When you prime factorize, you'll be getting this. See, whenever directly if a question is asking to you, how many factors does a number have? Okay, so if a number has how many factors, this is a shortcut to find out that. So when you prime factorize the given number, you will be getting the product of primes like this. Okay, so what you have to do is this product of primes you have to write as according to exponents. That means 2 multiplied twice means it is 2 square and 3 is there. So 2 square into 3 to the power 1 you will be getting, right? Then next step is you have to look at the powers of this prime number. So what are the powers of this prime number? That is 2. That is the power of 2 and 1. That is the power of 3. Then what you have to do is you have to take each power number and you have to add 1 to that. For example, 2's power 2 here, right? So you have to add 1 to that. Then 3's power is 1, right? You have to add 1 to that. So you'll be getting 2 plus 1 and 1 plus 1. Then you have to take the product of them. So you'll be getting 3 into 2. So the answer is 6. So that 6 is the total number of factors of the given number. That is 12. So just very simple only. You just need to prime factorize the given number. Write it as in exponents form. Okay. So after writing in its exponents form, you have to only see the powers. And you have to add 1 to the powers and take the product of them. Then you will be getting how many total factors are available for the given number. Okay, very simple, right? Okay, so moving to the next part. See, how to find out the unit digit. So these kind of questions are very familiar in nowadays examinations. So everyone, it's very simple only. See, whenever we are writing the power of 2, that is 2 raised to 1 is 2, 2 to the power 2 is 4. So likewise, we know how to find out. Power means what? Multiplying that same number that many number of times. For example, 2 to the power 1 means 2 only once 2 is multiplied. 2 square means 2 into 2. 2 cube means 2 into 2 into 2. So likewise. Okay. So here you can observe that I have listed out the powers of 2 up to 9. Okay. So you can see, look at only the unit digits here. What are the unit digits of the answers? 2, 4, 8, 6. 2, 4, 8, 6. Again 2. So there is a pattern. After every 4 powers, the pattern is repeating, right? That means 2, 4, 8, 6, 8, 2, 4, 6, 8. It is repeating like that. So we will understand that the number of possibilities of occurrence is 4 here. Okay. So whenever you are getting a number that is 2 to the power any bigger number, what you have to do is you have to express that power as a multiple of 4. And if any extra is coming, that you can write separately like this. For example, 2 to the power 15. Okay, so how you will write? So that you have to write as a product of 4. So sometimes reminder may come, sometimes reminder may not come. Okay, so here 15 is not exactly divisible by 4, right? So you can write 15 as 4 into 3, 12, 12 plus 3, 15. So here you can write it as 2 to the power 4 into 3 plus 3. So that means 2 to the power 4 into 3 into 2 to the power 3 according to the law of exponents. Right? Then 2 to the power what is coming along with this 4 into that you have to consider as 1. Okay. And then what is the remaining come? 2 to the power 3. So we know that 2 to the power 3, what is the unit digit? 8. So you'll be getting very simple. Whatever bigger number you are getting as the power of 2, you have to write as 4 into that. Plus if there is any remaining, you can write. So for 2 into 4 power whatever number is coming, you can write it as 1, take it as 1, and the remaining power what is coming, you only focus on what is the unit digit of that. Okay, and it is the same procedure we can have for 3. So let us see. You can see the power of 3 I have written. 3 and your unit digit are coming how? 3971, 3971, 3971. It will the same it will be occurring after every 4 power, right? So here also the possibilities are 4. So whenever a number is asking you to write 3 to the power 29, how will you write? You have to, here also 4 is a possibility. So what you have to do? You have to write the bigger number as a multiple of 4, and if there is any remaining comes, that you have to separately write as the power. So here 3 to the power 4 into 7 into 3 to the power 1, because 4 7s are 28. Here the number is 29, right? So 4 7s are 28 and 1 29. So 3 to the power 4, whatever it is coming, take it as 1, and 3 to the power 1, the unit digit of 3 to the power 1 is 3, right? The same procedure is for 7. So 7 to the power I have written here, and you can see the pattern and what pattern is coming here. 7931, 7931, 7931. Here also the possibility is 4, right? So when whatever number is coming, for example, here I have taken 7 to the power 125. So how that you'll replace it? 7 to the power 4 into 31. 4 into 31 is 124, right? And then 7 to the power 1 only remains. So then we'll write 7 to the power 4 multiplied, that is 1, and the remaining is 7 to the power 1. So the unit digit of 7 to the power 1 is 7. Okay. Then here in the case of 8, here also 4 powers, that is 8, 4, 2, 6, 8, 4, 2, 6, that pattern follows. Here also, for example, 8 to the power 82. So what do you have to write? 8 to the power 4 into 20. 4 into 20, we know that 18. Then 8 square. The remaining is 2, right? So what is the unit digit of 8 square? 8 square is 64. That is 4 is coming, right? So 8 to the power 4 multiplied whatever is coming, that term you have to consider as 1. Fine. Okay, everyone. So now let us see the power of 4. So powers of 4 are in the unit digit are having a pattern 4, 6, 4, 6, 4, 6, right? So here the possibility is 2. So what you have to do, whatever bigger number is coming as the power of 4, you have to express it as 2 into a number. So if remainder is coming, you have to write that separately like this, and 4 power that entity you have to take as 1, and the remainder, here it is 4 raised to 1. The unit digit of 4 raised to 1 is 4 itself. So if there is no remainder also, what you have to do is, you just need to write the possibility to that number. That is, for example, here the possibility of occurrence is 2, right? So you have to write 4 to the power 2. So if there is no remainder, you can directly write 4 to the power 2. The unit digit of this will give you the answer. That is applicable in all the cases. Okay. Now, here we can have the 9's power as 919191. That is the unit digit pattern. So here also the possibility is 2. So 9 to the power 2 into the bigger number, as you have to split up and write. And the remainder, if it is there, you can write that. And the unit digit of the remainder will be your answer. Okay. So here it is the 9 raised to 1. So the unit digit of 9 raised to 1 is 9. And the exception case are 0 to the power 0, 1, 0 to the power 105, 1 to the power 1000, 5 to the power 75, 6 to the power 87. That is all these kind of digits are having the unit digit are same. Okay. Now, test of divisibility is the next thing. So if you are very much aware of, I'm just giving you an brush up idea. Okay. So here, divisibility of 2 consisting of the unit digit as even numbers, right? Divisibility test of 3 is when you add the digit of a number, you should get a number which is divisible by 3. The same is in the case of 9 as well. When you add the digit of the number, you should get a number which is a multiple of 9. Then the number is divisible by 9. Here in this case, the number is divisible by 3. Divisibility of 4, the last 2 digits should be divisible by 4 or last 2 digits can be 0. Then divisibility of 5 in the unit digit 5 0 should come, 5 or 0. Divisibility of 6 is it should be divisible by both 2 and 3. It should satisfy the rule of 2 and 3 as well. 7 divisibility test is very simple. Whenever you are getting a number, for example 847, right? So unit digit what number is coming, take the double of that and you subtract that from the remaining number. For example 7, when you take it double, it is 14. So 14 you have to subtract from the remaining number 84. So the answer you are getting should be divisible by 7. Then the number is divisible by 7. Okay. And in the case of 8, divisibility, last 3 digits should be divisible by 8. Right. 9 divisibility already we discussed. When we add the number, the digit you are getting, the number as the resultant you are getting should be divisible by 9. Divisibility of 10 is the unit digit should be 0. And the divisibility of 11 is when you are given a number, you have to start counting the odd places digits, that is from the left towards the right. Here the odd places digits are 4, 6 and 4. So you add that, you will get a number, and even places digits are 0, 7 and 7. When you add that, you will be getting the number. Take the difference between them. So you will be getting either 0 or a multiple of 11. Then if both you are any of these you are getting, the number is divisible by 11. Then divisibility by 16, last 4 digits you have to check, and it is divisible by 16, then the number is divisible by 16. So now I can have a converting recurring decimals into fractions. See, we can have this type of numbers 1.753 bar. That means this number is 1.753, that this part is recurring or repeating, right? So this kind of expressions, how that we can write in the form of fractions, numerator by denominator. So it is very simple. You can use this formula a minus b by 10 raised to c minus 10 raised to d. So how that? What is a, b, c and d? A is the digit, the whole digit as it is we have to write. For example, here a 1753 as it is. Okay. B means how many non-recurring digits are in the order. So for example, non-recurring digits is 1 only here. So if for example 1.2753 bar, if it is so, you have to write 1, 2, right? So here only 1. So you can write B as 1. And C is the total number of digits after the decimal point. So here only 3 digits are there after the decimal point. And D is the total number of non-recurring digits after the decimal point. So we don't have any other number which is non-recurring after the decimal point. So that's why it is 0. Okay. So when we apply it in the formula, you will be getting 1753 minus 1 by 10 to the power 3 minus 10 to the power 0. You will be getting the answer 1752 by 999. Okay. So that's all regarding this video. So I hope everybody understood this. Please have a note of which you feel necessary. Okay. Thank you, and we'll see in the next video. Bye.